Lesson 7.3 is on multiplying exponents that have the same base. We'll look at examples or look at problems of why this is, or examples that will show us what the rule, or how to discover what the rule is. So a squared times a to the third. A squared means we have two a's multiplied together. A to the cubed means we have a multiplied together 3 times. I could rewrite this. This a is being multiplied together 5 times, or a to the 5th. 7 to the 5th means there are 5 factors of 7. 7 to the 4th means I'm taking 4 factors of 7. Put these together. Again, I count up how many times did I multiply 7 together. There's 5 here and 4 here, makes 9. 7 to the 9th. Now what this rule does today is takes us from here directly to here without having to rewrite the problem out as this repeated multiplication. And maybe you see already the pattern of how that happens. And the rule is that when you have these two bases multiplied together, we can add the exponents. So there's 4 examples here that'll show this. So first one, 7 to the 3rd times 7 squared. Should be 7 to the 5th. Try the next one on your own. Negative 2 to the 8th times negative 2 to the 5th. Take those powers here and add them. Should get negative 2 to the 13th. Works with negatives as well. Negative 5 plus 8 would be m to the 3rd. And the last one, we see the exponent of 2 and 4, and then here, this last x really has an exponent of 1. Take those powers, add them all up together, x to the 7th. Be careful to combine powers that have the same base. We can only combine powers that have the same base. So here we've got these values are actually being multiplied all together. So there's multiplication between all of these. The commutative property says that I can multiply in any order. I can move things around. So I could take these together. It would give me 8. And then multiplying these together. Multiplying these together. Add my powers. Next problem I see, I've got an exponent here of a 1. That's my first step, is to write that missing exponent in there. I'm going to multiply the numbers together first. Then I'm going to take the a values. So a to the 3rd, a to the 1st, gives me a to the 4th. And then last is the b to the 4th. Same with the next problem. First thing I'm going to do is, if the exponent isn't showing, I'm going to put a 1 there. Multiply my numbers together first. Those coefficients, numbers in front, coefficients. And then look at powers. So I've got the x, this one has a negative 5, a 1, and a 7. So x, if I add these all together, negative 5 plus 1 plus 7, I get x to the 3rd. And I do the same thing with my y values. One and 6 is 7. With scientific notation, it's really the same thing. Multiply these two together first on their own, we get 8. Multiply these two together on their own. So you're taking 10 to the negative fifth times 10 to the negative second. And our rule that we learned today said we got to take these powers and add them. So this really becomes 10 to the negative seventh for my exponent. In this problem, we get 35, multiplying 7 and 5 together. 5 to the third times 5 to the fourth. We're going to add those powers together. Excuse me, 10 to the third times 10 to the fourth. We get 10 to the seventh. Final answer. Or excuse me, not my final answer. Just wait. This isn't my final answer because this isn't scientific notation. 35 has a decimal right there. Proper scientific notation says we need our decimal there. We need one number in front and then our decimal. So we're trying to figure out what number should go there. So this is what we talked about yesterday. Right now, this decimal is moving 7 spaces to the right. And to be proper scientific notation, we'd have to go here. To get to the same place, we'd have to move 8 spaces to the right.